Hi, I'm Lee Teschler with EE World and Design World, and I'm here with Mark Adams from CUI, and we're talking about something called software-defined power. Mark, I'm not sure everybody knows what software-defined power is. Can you help us out with that?
Absolutely. So we've heard about a lot of aspirations of software-defined data centers and everything else, and software-defined power is what we see as the next evolution of power. What we mean by that is that, digital power came around about 10 years ago, right? As we like to say, is the scarecrow effect, right? You've added a brain. If I only had a brain, well, the power supply ended up getting a brain, and it was very focused. It was very focused on the point of load area, or the intermediate bus converter area, or the front end power supply. They came out with things like PM bus for communication protocols, but it was very point specific, right? Independent solutions solving independent ideas. So what we're trying to do is we're now taking that next generation or that next step up. So it's adding that intelligence outside of the power supply. So how can you create really an ecosystem managed by software to orchestrate what the true impact can be? Because in an ecosystem, right, the sum of the individual pieces is greater than individual pieces. So we think that that's the next logical evolution of power going forward, is orchestration of this intelligence and making smart decisions.
Now, who's the architect of that? When you're usually defining a power supply, it's a guy who knows magnetics and stuff like that. You're talking more like about a guy who's a software guru.
Absolutely, and so as part of this, in order to make things happen, what we feel is we really needed to create a collaboration. So one of our first collaboration partners is a company called Virtual Power Systems. And what we're doing is we're driving there into the data center. So we're able to take our power supplies that are already front end and add a different layer of complexities. So what Virtual Power Systems does is they do a load share or a peak shaving application. So what we have is we have a 4U 12 kilowatt unit that's a series of battery modules and power control modules. So being able to, let's say a rack is 10 kilowatts. What they'll do is they'll put 16 kilowatts of power in there in order to over partition, just in case, right? It's if all of a sudden somebody actually finds Elvis out there and the internet's going to come and there's going to be a lot of traffic. But in reality, what they're using is about 60% of the power. So it's a 6 kilowatt rack. So how do you manage that without having to put all that extra power in there? So what we do with this unit is we pull from the battery. So when 6 kilowatts of power is being consumed and all of a sudden now it goes to 7 kilowatts, rather than pulling it from the grid and paying for it, what you're able to do is you're able to pull from the battery that's there. So the energy storage, right? It's one of the next evolutions that I'm sure of this show is going to be how do you manage and gain energy storage. So now we're able to do that, and when the power need goes below 6 kilowatts, then we're able to charge the battery. And it's a self-learning algorithm, so that 6 kilowatts is dynamically adjusted because what they're doing is they're gathering data points twice every single second to make that decision on when should we charge, when should we pull, and make those decisions. So when it's all added up, what you're going to do is you're going to end up saving about 15% in your operational expenditures in the data center, and a 60% reduction to even implement it. So the capital expenditure is much lower than traditional systems as well.
Mark, it's an interesting development, so thanks for sharing it with us.
Absolutely, we're excited about it.